4.3, Law of Logarithms. So since logarithms are exponents, the law of exponents led the way to the law of logarithms. We use the same principles. So when you have log base A of AB, A is multiplying B, so we use the exponent property. When they're multiplying, you add them. So you separate it into log base A plus log base A, B. Law number 2 is log base A of A over B. A divided by B, just like an exponent, is when you divide, you subtract. So you split them up into log base A minus log base A, B. Number 3 is log base A of A to the C. We take the exponent and we move it to the front to be the coefficient. So you got C times the log base A. We are now going to use those logarithms. We're now using the law of logarithms to expand the expressions. We're starting with log base 3 of 7x squared y. The base is 3 and it will stay 3 when we expand it, and 7 is multiplying the x squared, which is multiplying y. So each of these have to be split up, so we will have 3 logs adding together. So we will have log base 3 of 7 plus log base 3 of x squared plus log base 3 of y. We can't have exponents in the log, so we're going to move the 2 to the coefficient. So you get log base 3 of 7 plus 2 log base 3x plus log base 3y. The next one is the log of the square root of 23. 23 is not a perfect square, so we need to express the square root as a fraction exponent of 1/2. Log of 23 to the 1/2. So now we're going to just move that 1/2 to the coefficient to get 1/2 log 23. The next one, you got the natural log of 18x squared over xy to the third. Now this one's going to look better if I handwrite it out originally. ln of 18x squared over xy to the third. We have x's on top and bottom. We need to simplify those. X squared over x goes to x on top over y to the third. So now we need to split it up. 18's multiplying the x, so that goes to ln of 18 plus the ln of x, and then it's all being divided by y to the third, so minus ln of y to the third. Last thing, take the exponent, move it to the coefficient spot. So our final answer, you get ln of 18 plus ln x minus 3 ln y. We are now going to go backwards, and we'll get the expanded expression, and we need to write it as a logarithm. So the first thing you're going to look for is the coefficients. If there are coefficients on the log or the natural log, you need to move them back to the exponent spot. So this has a coefficient of 5. We're going to move it back up to get log x to the 5th. The 1/2 goes back up, so plus log 6 to the 1/2. But we express 1/2 as a square root. So you got log of x to the 5th plus log of root 6. Now you look to see whether the terms are adding or subtracting. They are adding. So adding was our law 1, where they go back to multiplying. So you get log x to the 5th root 6. Our next one has the ln of 7 plus 2 ln x minus 81, that's 8 times ln of x minus 11. So you once again look for the coefficients first and move them back to the exponent. So the 2 and the 8. Now the 8 is the exponent of the entire quantity x minus 11. So we got ln of 7 plus ln of x squared minus ln of x minus 11 to the 8th. So we're going to go left to right. The first two terms are adding, so you are going to change them to be multiplying ln of 7x squared and bring down the minus ln of x plus minus 11 to the 8th. Now these two terms are subtracting, so we write it as division. ln of 7x squared over parentheses x minus 11 to the 8th. We are now going to evaluate the expressions by using the law of logarithms and then converting them to exponents to evaluate. So we're starting with log base 4 2 plus log base 4 32. Now they must be the same base. And they are. In this one it's 4. So they're adding. We're going to rewrite them as multiplying. Log base 4 of 2 times 32, which goes to 64. And now we're going to convert that to an exponent. So we set it equal to x, and we're saying 4 to the x equals 64. 4 to what power gives you 64? 4 to the 3rd power does. So our answer is 3. Our next example, log base 2 of 80 minus log base 2 of 5. They're the same base of 2. They're minusing, so we write it as division. Log base 2, 80 over 5. 80 divided by 5. You get 16. So log base 2 of 16. Set it equal to x. Convert it to the exponent. 2 to the x equals 16. 2 to what power gives you 16? To the 4th power. So our answer is 4. Our last one is a little bit different, negative 1/3 log 8. So we're going to start by moving the coefficient to the exponent to get log 8 to the negative 1/3. 8 to the negative 1/3 goes to 1/2. Now there's no base written, so we know it's base 10. So 10 to what power gives you 1/2. This is where the calculator comes into play. We can plug this in. Log of 1/2 is negative 0.301. Our last equation for the day is for change of base. And we use this to write logs in base 10 or with natural logs so that we are able to evaluate using calculators. So the formula is log base b x. We put it over log base a, x over log base a, b, where the b comes from the original base. Now typically if we want a to be 10, so that they're log base 10, and we can plug it into the calculator. So our first examples is we are going to use the change of base formula to evaluate log base 8, 23. So let's identify b and x. B is 8, x is 23. And we want a to be 10, so we can evaluate. So log base 8, 23 goes to log base 10 of x of 23 over log base 10 of 8. So we can now plug this into the calculator. Remember, the calculators do log base 10 naturally, so you don't have to put the 10. So log of 23 goes 1.36. Log of 8 is 0.9. So that log of 23 divided by log of 8 goes to 1.5. You can also use the change of base formula to graph logarithmic functions. There's an example in your book on page 362.